Welcome back to the Network Engineer Diaries. I'm your host, Jimmy Shaka. As promised in the previous video, here we're going to talk about extended and standard named access control lists. We have the same topology as the previous one in the previous video. If you haven't watched the numbered extended and standard ACL video, go ahead and check out the link in the description section below. We have this topology here that consists of 5 computers, computer 1, 2, 3, and 4 in the 10.0.0.0 subnet, and we have PC5 up to the top left hand corner that's in the 10.0.1.0/24 subnet. And then we have 2 switches, switch 1 and switch 2, and then 2 routers, router 1 and router 2. Using Packet Tracer, we are going to configure named extended and standard access control lists on router 1 to perform these tasks that we have here. Before we do that, I have configured telnet and static routes on router 2 to permit traffic coming in from these computers, telnet sessions and pinging sessions. Okay, let's get started. Before we get started, on router number 2, the user exec mode username is Jimmy Shaka and the password is Cisco. And to access the global config exec mode, the password is Cisco admin. Okay, the first task is asking us to use a standard named ACL on R1 to deny traffic from all PCs in the 10.0.1.0 subnet. So we are going to forbid computer 5 from being able to reach R2 using a standard named ACL. Before we get started, we can check and verify that these IP addresses have been configured on these devices. PC1 has been set up with its corresponding IP address and subnet mask and gateway IP address. Same thing is for PC2, laptop 2, laptop 3, laptop 4, PC4, and PC5. On routers, we have also configured IP addresses on the interfaces. Okay, as per this topology right here, we have IP address 10.0.0.9/24 on fast Ethernet 0/0 facing towards the computers 1 through 4, and then we have 10.0.1.1/24 on fast Ethernet 1/0 facing towards PC5, and then we have 10.0.10.1/24 on interface fast Ethernet 0/1. This interface is facing towards R2, and the same is for R2. We have 10.0.10.2/24 on fast Ethernet 0/1. Okay, let's get started with task number 1. Using standard named ACL on R1 to deny all traffic from PC5 from reaching R2. Before we do that, we can check and verify that PC5 right now has the ability to ping router 2 successfully. It can also telnet to R2. It is asking for my username and password Cisco. To reach the global config mode, the password is Cisco admin. Okay, show the running config. So we are inside router 2 using PC5. So we are going to deny the pinging and telnet session. We are going to block it from being able to reach R2 coming from PC5. So go on R1. First of all, we are going to create that ACL, that standard named ACL. The way you do that, you go to the global config, and the syntax for that is access list standard IP access list standard. We give it a name, block. Let's give it a name, PC5 to R2. Okay, the ACL has been created, and now we're going to enter a series of access control list entries to permit or deny traffic. So deny 10.0.1.0 inverse of the subnet mask, the wild mask of 0.0.0.255. Next, we're going to permit the rest of the other computers which are in the 10.0.0 subnet with the wild mask of 0.0.0.255. So what we're saying is, if the traffic comes to R1 coming in from PC5, go ahead and block it. But if it comes in coming from PC5, but it's intended to go to this subnet 10.0.0.0, which is the 4 computers that are down here, we're telling R1 to go ahead and permit the traffic to go through. Next, we are going to go to the interface level, interface fast Ethernet 0/1, and we're going to apply this ACL to that interface. Okay, the way you do that is IP access group, then the name of that ACL. Remember earlier with the numbered ACLs, this was going to be the number of the ACL. Since these are named ACLs, you are going to use the name that you used above earlier when you created the ACL. So IP access group block, okay, and you're going to specify whether it's in or out. It's out because the traffic is coming in from PC5 and going out fast Ethernet 0/1 heading to R2. So we're applying this ACL on that interface, so it's out. Okay, if we check, let's verify and see that PC5 is not able to ping R2 anymore, or telnet to R2 anymore. Okay, we can first of all check and verify that the computers can still ping each other. So PC5 can still ping PC1, computer 1 through computer 4. So we still have connectivity between the computers. Okay, so that's good. PC1 and PC5 have connectivity to each other. PC2 to PC5 is good as well. How about PC5 to PC3? That's good. PC5 and PC4, that should also be good. And then we're going to test connectivity between PC5 and R2, see if the traffic gets blocked. Okay, so that was successful. Traffic between PC5 and PC4. Now let's try to ping R2 at 10.0.10.2. we shouldn't be able to see the destination. The destination host is unreachable. So that's what the ACL that we just configured is doing. It's blocking all traffic intended for R2 coming in from PC5. How about telnet? We won't be able to telnet either. We shouldn't be able to. See? R1 is blocking the telnet session as well from coming in from PC5 trying to reach R2. So that's good. The first task is complete. Let's move on task number 2. So we're going to use extended named ACLs to allow computer 3 and 4 to telnet to R2, but computer 1 and 2 would not be allowed to telnet to R2. But all computers, all other connectivity to R2 must be maintained. That means computer 1, computer 2, computer 3, and 4 should be able to ping R2, but only 3 and 4 should be able to telnet to R2. 1 and 2 should not be able to telnet to R2. Okay, go back to R1 and go to the global config mode. Before we do that, let's demonstrate and see that we still have the ability to ping and telnet to R2. PC1 is able to telnet to R2. Okay, computer 2 is also able to telnet to the router. See, it's asking for my username, password Cisco. So we are on the router now. 3 and 4 also have the ability to telnet to 10.0.10.2, which is router 2. Username is Shaka, password Cisco. See, all these 4 computers down here, they have the ability to, they have been configured to be able to telnet to the router. Username, password, oops, wrong password. Okay, see, PC4 is able to telnet to R2. Next, let's configure the ACL, the extended ACL, to block PC1 and computer 1 and computer 2 from telnetting to R2 as per this task requirement down here. Okay, alright, the way you do that is, first of all, you create the ACLs. Okay, and these are going to be, syntax is you start with IP access list extended, give it a name, let's say allow PC3 and PC4 telnet. Okay, allow PC3 and PC4, okay, to telnet. The typo here, access list. Okay, next we're going to create a bunch of access control entries to permit or deny the traffic. So the first one is permit TCP host 10.0.0.3, that is computer 3, to reach router at 10.0.0.10.2. okay, on the port telnet. Next, we're going to permit host number 4 also to be able to reach router number 2 on the telnet port number 23. The next ACL entry is deny TCP, to deny all other TCP traffic coming in from other computers in the 10.0.0 subnet. Okay, 225 trying to reach router 10.0.10.2 on the telnet port. On the telnet port. Okay. Lastly, you have to permit all other traffic, because that's what the last requirement was. All other connectivity to R2 must be maintained. So the way to do that is permit IP any, and then we exit out of here. Exit. Let's go to the interface fast Ethernet 0/0. Now we're going to apply this extended named ACL on that interface fast Ethernet 0/0. We're going to say IP access group, the name of the ACL we created, which was allow PC3 and PC4 telnet. So that was the name of the ACL, and you're going to say, so the traffic is going to be coming in from the bottom, and it's going to reach R1 on the inside interface fast Ethernet 0/0. It's going to go out of fast Ethernet 0/1. Okay, we have already configured an ACL on that port. Fast Ethernet 0/1. We can only apply one ACL per interface, so fast Ethernet 0/0 is already out with the previous ACL, the standard ACL from PC5 that we applied on fast Ethernet 0/1. So the only option that's left is to apply this new ACL, the extended named ACL, on fast Ethernet 0/0 on the inside port. So in. Okay, so that is complete. Let's verify and see. The first verification is, let's check that 3 and 4 can ping and telnet to R2. Ping router number 2, 10.0.10.2. The ping is successful, so we're getting replies from R2, so that's good. How about telnet? Can we telnet to R2? Telnet to R2. It's asking for my username, Cisco password. So Cisco admin. See, we are on the router now using computer 3. How about computer 4? Computer 4 should also be able to ping the router. So the ping is successful. We're also getting replies from router number 2, so that's good. How about telnet to 10.0.10.2? The telnet is also good, and to reach the global config exec mod, the password is Cisco admin. So we are now on the router, inside the router using PC4, so that's good. So 3 and 4 can ping and telnet to R2. How about PC1? PC1 should not be able to telnet to R2 per our new ACL configurations. Let's test that. Telnet to 10.0.10.2. See, it's denying the telnet session towards R2. But if we ping R2, we should be able to do that. So the ping is good. So let's try that on PC2 as well. Let's verify. Can we telnet to 10.0.10.2? We shouldn't be able to telnet. You see, the telnet is being denied. The telnet to the router is being denied, but we should be able to ping the router. See, the ping is successful. Also, computers can communicate between each other successfully. Let's verify that. Let's ping computer number 1. So that's good. How about number 3? So that's good. 2 and 3 can communicate. How about 2 and 4? That is also successful. How about 5? Oops. 5 is in a different subnet, 10.0.1.5. It's also successful. Great. Guys, so that's how you configure standard and extended named ACLs to block or permit traffic through a router at the interface level. Thanks for watching. I'll see you in the next video.